Now let's design a movie recommendation system. I probably don't have to do much of a background on this, but think of something like Netflix or even just a generic video service like YouTube, where users watch movies or videos and they might rate them. For example, a 5-star rating, or it could be like a thumbs up or thumbs down. But usually based on some type of user data, we can build a recommendation system around it so that users can automatically see which types of videos or movies that they might like. Now, this is a pretty broad problem, so how can we narrow this down? Some good questions to ask are, how will we rate the movies? Will we even need to do that in the first place? And if we do, I guess it probably will be users that are rating the movies themselves. And the next question is, how are we going to recommend movies based on these ratings? Are we exclusively going to use these ratings, or are we going to use some other type of heuristic? Is it up to us how we want to calculate it, or is there a specific algorithm that we want to implement and we're going to design around that algorithm? Also, roughly how many movies and users are we even talking about? How many ratings are we talking about? I don't know how important this would be, but it might change the design in terms of how optimal we want our design to be. Maybe if we have a relatively small amount, we don't have to worry about being super efficient. Maybe we can talk about some edge cases, like what if there is a tie in the movie that we are recommending? When we recommend a movie, are we just recommending a single movie, or are we doing multiple movies? If it's just a single movie, what if our recommendation system has a tie between two movies? Which one do we choose? And how would we recommend movies to a user who has no movies that they've seen yet? So this is like a new user. We don't have any data on them. How are we going to recommend movies to them? Well, to answer most of these questions, how we will rate a movie, we're going to go with a star system. So 1 through 5 stars, or a movie could be unrated if a user just hasn't rated the movie yet. Users will be responsible for rating movies. They will be the ones providing the 1 through 5 star rating. The way we are going to recommend movies, we'll start with a simple case. If a user has not watched any movies, we don't have any data on them, so we can't really take any shortcuts. The easiest way to recommend a movie to them would just be to go through all of our list of ratings, find the movie with the highest average rating. If there's a tie, it doesn't really matter which one we return. For simplicity, let's just say that if there's a tie, we can return any of them. But for a new user, that's the simple case. We just return the highest rated movie on average. What if we do have some data on that user? Maybe we can give an even more intelligent answer. Well, one, we definitely want to return to them an unwatched movie because we know which movies they've seen before, so we definitely don't want to give them one they've already seen. And second, this is going to be a bit open-ended. The movie that we recommend to this user is going to be based on other users who have a similar interest to this user. And among those users, we want to find the user that has the highest similar interest and then return one of those movies that they've seen, but this user has not watched yet. And you could generalize that even more. We want to create some type of intelligent rating system where we have data on other users and we want to find users that have similar interests so that we can find a good movie for this user. It's up to us on how we want to define that exactly, but I'm going to handle it a pretty simplistic way, though it could be extended, but it's not really about finding the most complicated way that we can implement this, though I encourage you to try out your own ways. At a high level, these are most of the requirements. Let's now try to dissect this high-level design. We're going to sort of have to think in reverse because this is a bit challenging in how we're going to represent all of our data. So at a high level, we are going to have users, which is mainly just going to be used to encapsulate some information about the user, maybe uniquely identify them as well, give them like a user ID. And similarly, we're going to do the same for movies, though a movie could have additional information, things like the title of the movie, but we probably also want to be able to uniquely identify them as well, because who knows, maybe some movies have the same title, so we'll give it an ID as well. Now you might be thinking, are we also going to store the ratings on the movie? I think it's better to not. The movie itself should not be responsible for knowing ratings that users have provided to it. I think it makes more sense to have a separate class for that. I'm going to call it the rating register. You could call it the movie ratings or movie rating register. It's up to you. Remember, the way ratings are going to be represented is going to be 1 through 5 stars. I think it makes sense to have an enum for that. So an enum, maybe we'll call it the movie rating, and that's how we're going to store a particular rating. Now, before we get too deep into the rating register and the functionality that we're going to need this to provide, let's talk about the actual recommendation system, because knowing how that works is going to inform us on how we should build our rating register. So with our recommendation system, there's really one public method that we want to implement, and that is to recommend a movie given some user. So given a user, we want to recommend them a movie. Now there's two cases. The simple one is that this user hasn't even seen any movies yet. How would we know that from our recommendation system? Well, we do have our rating register that's going to store all of the ratings. So if this user hasn't rated any movies, we'll assume that they haven't watched any movies. How will we know that from our rating register? And let's say we want to do it somewhat efficiently. Well, we could have a hash map in our rating register that maps every user or user ID to the list of movies that they have seen before, because this is also going to come in handy when we need to intelligently recommend based on the user's interests. So having a list of the movies that they've seen is going to be helpful. In this case, we would know a user hasn't seen any movies because their list of movies is empty. So in that case, for this user, we would want to find the highest rated movie and then recommend that to them. Well, I think it also makes sense to have another hash map which maps every movie, or probably movie ID, to a list of the ratings, and not just a list of ratings, but here we should probably have another hash map. Well, it might not be obvious at first, but you'll see why when we get to the code. We should have another hash map here which will map a user to the rating that they provided. So with that, if all we want to do is take a movie and get all of its ratings, it should be easy because we can map the movie to this hash map and then just get the values from that hash map, calculate the average, and then find the movie with the highest average and return it to the user. But if we're going with the more complicated case, where for this user, we want to find other users with similar interests, what we would do is for this user, we would possibly iterate through every other user and find the intersection of movies that they have both watched. And then for that movie, we can, using this second hash map, using the movie and the user key, we can find the rating that that user provided the movie. So we can compare two users, user 1 versus user 2. What was the rating that they provided? If both of the users provided a similar rating, then that means they might have similar interests. And then if we want to recommend a movie to user 1, we can find a movie that user 2 has watched that they gave a high rating to, but user 1 hasn't seen that movie before, and we can recommend that movie to user 1. This is at a high level. It won't make a ton of sense though until you actually dig into the code, but these are the kind of main motivations. But this is definitely not a super straightforward problem, and there's probably many different ways to implement it. I definitely encourage you to try your own. But now let's take a look at the code. So let's start with our movie and user class. In this case, they're both going to have a unique ID. The movie is going to have a title. The user is going to have a name, but we're not really going to be using the name very much. Of course, you could extend these classes to add additional information. We're going to have an enum to represent the movie ratings. Not rated is going to default to 0, and 1, 2, 3, 4, 5, they're going to have integer values, because this might come in handy when we actually want to calculate how similar two users' interests are. Now for the rating register, the main data types are going to be what's most important here. We're going to have a hash map mapping a user ID to the list of movies that that user has watched, just like we kind of briefly talked over. We're going to have another hash map mapping the movie ID to another map, where we can then use the user to find what rating that that user left. Well, we'll have to use the user ID. And for convenience, we'll also have a list of movies and list of users. When we add a rating, we have to handle a couple edge cases. We have to check if this movie has not already been added before to our movie ratings hash map. Then we'll have to create a new hash map using the movie ID as the key, just so that there is like an actual hash map there so that we don't access null. And to our movies list, we're just just going to append that movie because it's the first time we're seeing it. Similarly with the user, if the user is not already in the user movies hash map up here, then we're going to create an empty list for them because that's the data type we're going to be storing, and we're going to append the user to the users list. Handling those edge cases, then we're actually going to add the rating. So in our user movies hash map, we're going to use the user ID as the key and then append the movie to the list. With the movie ratings, we're going to use the movie ID as the key and then use the user ID as the second key and then insert the rating that they have left. Those are the three parameters as well, the user, movie, and the rating, just as you would expect. And maybe this could have even gone in the recommendation class, but I think it makes enough sense to have it here. Given some movie, we can easily calculate the average rating for that movie. Well, if it's not been inserted yet, we should probably return the not rated value. But if it has, we will get the movie ratings and call values on it because we know that when we use the movie ID as a key, then we get this hash map. We don't want the user IDs, we just care about the ratings. So by calling values, we just get the ratings. And then for all of those ratings, the rating itself is an enum, remember? And in Python, you just have to call dot value to get the actual value in this case, which is an integer, which is what we want. And then using those integer values, we can take the sum of all of them and then divide by the length, which will give us the average, of course. Other than that, we just have a few convenience getters, getting the list of users, getting the list of movies, getting all the movies that a user has seen, and getting the movie ratings map for a particular movie. Now for the actual bulk of the code, we have our recommendation system. At a high level, it's pretty simple, and I don't think in a real interview you would have to get too much into the details. I think I wouldn't expect you to, because this is definitely really involved and it's easy to make a bug. It's obviously a lot of code here, but I think at a high level, which is what's important, is we need to know if this user has seen any movies yet. We can do that by checking our movie ratings register, getting the list of movies that user has seen. If the length of it is 0, then we need to recommend a movie because based on this being a new user. Otherwise, we would recommend to an existing user, and we're going to handle both of those differently. Recommending to a new user is going to be mostly straightforward. We're going to get all of the movies, and for every movie, we're going to get its average rating. If the average rating is bigger than our best rating that we've seen so far, then this is going to be the new result. If it's not, then we continue. But eventually here, we will return the movie title with the best rating. If we couldn't find one, then we just return null. That's not too complicated, but this part is a bit more involved, recommending to an existing user. Our goal is still the same. We want to find the best movie, but in this case, we want to do so based on a similarity score. So this is the user we're trying to recommend to. To recommend to them, we have to find other users, which we're going to call reviewers, just to not confuse ourselves too much. But we're going to go through all the list of users and we're going to check, is this reviewer not the same as the user that we're trying to recommend to? Because if we use the exact same user, then their similarity score is going to be pretty good. By the way, this similarity score is set to infinity, but lower is better. So we set it to infinity the way I'm calculating it, at least. We're going to try to minimize this. If it's 0, that means the two users have as close to a similarity score as possible. And I have a helper method to calculate that similarity score given a user and a reviewer. If we find a new similarity score that's smaller than our current one, then we update it and we use this reviewer to recommend us an unwatched movie from user 1. And then using that movie, we set it to our result. It's possible though that this recommend unwatched movie will return null, because what if both of these users have seen the exact same movies? Then reviewer doesn't really have an unwatched movie to recommend to the first user, so we handle that here with a ternary operator. Ultimately, we are going to just return what that movie is if it wasn't null. If it's null, then we just return null. I don't think it's super important to get into the details of the similarity score calculation and the recommend unwatched movie. The high level is what's most important. I'll talk about how we're using the hash maps that we defined all the way up here in the rating register. First, for the similarity score, we have two users. With our ratings register, we get the movies that one of the users has seen before. we arbitrarily pick user 2. It's not super important, but we go through this list of movies. But for every movie, we get the movie ratings hash map. What is that again? That's this map over here. We're given some movie ID, then we have a map of every user who watched it and what was the rating that they left that movie. That's what's important here. That's what we're going to use to calculate the similarity score. Back down here, given that hash map, first, we have to make sure that user 1 has also seen this movie, because this is just the list of movies user 2 has seen. But if user 1 has also seen this movie, then this is the intersection. Both of the users have seen the movie. First, this is just sort of an edge case. If our score is still infinity, we set it back down to 0. But most importantly, we take the difference of the scores, the ratings that both of the users left it, the difference between the rating that user 1 left it and the difference between the user that rating 2 left it, and we take the absolute value of that because it could be positive or negative depending on which value goes first. But we take that and add it to our similarity score, and then we return the similarity score. You could say maybe we should also calculate it based on the average of the numbers that both have seen before, and I would agree with you, but I think the goal is not to make this as complicated as possible. Of course, we could extend this and make it even more complicated based on the data that we have. Maybe we could even have time series data. We could have stored what time a user watched it, and we would weight the movies that users have seen most recently as higher than movies that they haven't seen recently. But this is just a very, very basic recommendation system. Now, if 2 users have watched similar movies before and we want to recommend a movie to this user from this reviewer, well, we would just go through those lists of movies, make sure that this user has not seen that movie before, and that the movie from this reviewer has a relatively high rating. The way we're doing that is just by finding the max rating of movies that this guy has not seen before, and then we return that movie. So not insanely complicated, but it's definitely hard to wrap your mind around all the relationships and what types of data types we should store, like how we should create our hash maps. And there's definitely different ways to do this. But an example usage could look something like this, where we create a few users, we create a few movies, we add some ratings. So in this case, user 1 is rating movie 1 and 2. User 2 is rating movie 2 and 3. User 3 did not rate any movies, so the movie that we recommend to them is going to be the one with the highest average rating, which is movie 1, Batman Begins, with a score of 5. For user 1, we recommend them a movie that they haven't seen before. They have a very similar interest as user 2 because they both rated the second movie with the exact same score, so we recommend user 1 a movie that they haven't seen, which is just movie 3, The Godfather, and user 2 the same thing. They haven't seen the first movie, which is Batman Begins, so we recommend them that movie. While this is complicated, I do think it's pretty interesting as well, because this is very clearly extensible in so many different ways depending on what types of data that we're storing. It has a good combination of high-level design as well as interesting low-level implementation details. I'm sure you have different ideas of how this could be implemented, so definitely try them out.